Okay, so we're going to solve the equation cosine 2 theta equals a half. There's a couple different ways to go about doing this, and this is the method that I use. The best way to handle it is to first look at the graph, and then we'll go from there. We'll do the nuts and bolts of solving the equation. First off here's the graph of cosine 2x from the distance from 0 to 2 pi. So notice cosine, there are two total cosine functions within a span of 0 to 2 pi. So notice that it takes a distance of pi for one cosine function to complete its cycle or its period, and then another distance of pi in between pi and 2 pi for another total cosine. So how many solutions are we going to have? So the second function, the horizontal line, is 0.5 because that's what the equation is. Cosine of 2x is equal to a half. So it's 2 theta, excuse me. So 2x, 2 theta, same thing. So we're going to have four different solutions here. So the way that I handle this is, first thing I do is just graph regular cosine. So let's take a look at that. So here is cosine x. It's just this trig function drawn here. And I've done it over a distance of 4 pi. So I've drawn two complete cycles of cosine. Just like before with cosine 2x, we had two cycles of it fit into a span of 0 to 2 pi, where one of them went from 0 to pi, and then the second one went from pi to 2 pi. I'm just going to stretch out the cosine function and just have two complete cycles, but I'm going to spread it out from 0 to 4 pi. And notice that there are four intersection points where my function intersects 1/2 at pi over 3 and 5 pi over 3. And then notice that the distance from pi over 3 to 5 pi over 3 is just a distance of 2 pi. So these two angles are coterminal on the unit circle. They're just in a different form because they're on the Cartesian plane here, not in the unit circle. And then 5 pi over 3 and 11 pi over 3, those two are coterminal as well. So I first find my two 0 to 2 pi solutions to cosine equals a half. And then I find the coterminal angles of all of those. And then what I do is I take my graph, which I'm going to show you in a second, and I squish it back to fit between the distance of 0 to 2 pi, because all of my answers must be between 0 and 2 pi. So therefore I'm going to take this whole graph and squish it back to the one I showed you before, and I'll have the four solutions that I get from pi over 3, 5 pi over 3, 7 pi over 3, and 11 pi over 3. Well, if I take this whole thing and squish it in half, or if I divide it, or if I change the period to half as long as it is, well, I'm going to take all these four answers and divide them all by 2 as well. So I'm going to get pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. Let's take a look at that. So this may be a little bit too much to look at, but here is so on my original cosine function, which is the big long one, I had pi over 3, but then I divide that by 2 and I get pi over 6. I originally had 5 pi over 3 on my original cosine function, and then notice this shorter function, the ordered pair, excuse me, the point is 5 pi over 6 comma 1/2. So I just took this point, divided it by 2, and got this one over here. Again, on my original long cosine function over a period of span of 0 to 4 pi, I had 7 pi over 3. I divide that by 2, I get 7 pi over 6, which is this point right here, and notice it's still within the region of 0 to 2 pi. So again, I took the long function, I cut it in half, and I put two of them in a span of 0 to 2 pi, so my four solutions will just be spread out amongst this shorter interval right here. And lastly, my final answer on the original cosine function was 11 pi over 3. I divide that by 2, I get 11 pi over 6. So therefore, these two answers, this answer helps you get this one here by taking this original very long cosine function, cutting it down so it only takes half the distance for it to complete one period, and then I get my four answers of 11 pi over 6, 7 pi over 6, 5 pi over 6, and pi over 6. So what was the idea? I take pi over 3, I add 2 pi to it, I get 7 pi over 3. I take 5 pi over 3, I add 2 pi to it, I get 11 pi over 3. Then I take all four of these answers, divide them all by 2, and I get 11 pi over 6, 7 pi over 6, 5 pi over 6, pi over 6. So let's take a look at the problem over here. So what I do is I imagine that this is just cosine theta. So I have cosine, I'm going to let 2 theta equal a random variable, I'll call it w. W equals a half. So this is true when w is equal to pi over 3, and in the fourth quadrant, which is 5 pi over 3. I'm going to add 2 pi to both of these, which is the same as 6/3 pi. So pi over 3 plus 6/3 pi, 6/3 is 7/3 pi. And 6/3 plus 5/3 is 11/3 over pi. So W in this case gives me the four answers of pi over 3, 5 pi over 3, 7/3 pi, 11/3 pi. And you notice those are the four angles that I have right here highlighted in pink. Well, since W is equal to 2 theta, 2 theta is equal to W, so I can just replace 2 theta here. So I want to get theta all by itself. That's my goal, solve for theta. So if I want to get theta all by itself, I need to multiply this by a half and multiply this whole side by a half. So I get theta equals pi over 6, 5 pi over 6, 7 pi over 6, 11 pi over 6. So you'll notice here's cosine 2x. There's two complete cycles of it in the region of 0 to 2 pi. And my four answers are pi 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. Okay, so I have cosecant 3 theta. So the easiest way to handle this is I'm going to make this the sine of 3 theta. And I'm going to reciprocal both sides. So cosecant turns into sine, and 2 turns into negative 1/2. So if I have 3 theta, that means the period of the sine function is 2 pi over 3, or that there are going to be 3 sine functions within the region 0 to 2 pi. Just like before, there were 2 cosine functions from 0 to 2 pi. There are 3 sine functions here. So let's take a look at that function. Okay, so first off, here's my sine 3x function. Here's negative 1/2, which is the horizontal line down here. I'm going to have 1, 2, 3, 4, 6 answers, as opposed to earlier I only had 4 answers. That's the maximum number of answers that you can have. So it'll be the maximum number of answers you can have is twice the coefficient of x. So I have 6 total answers. So notice that there are 3 sine functions. So this is one complete sine function from 0 to 2 pi thirds. Another distance of 2 pi thirds is going to give me 4 pi thirds. That's 2 complete sine functions. And then add another 2 pi thirds to 4 pi thirds, you get 6 pi thirds, which is the same as 2 pi. So therefore, there are 3 sine functions, hence that's why there are 6 answers. So maximum number of answers you're going to get is double the coefficient of the value of x. So let's take a look at the sine function from 0 to 6 pi, get those coterminal angles, and then we're going to squish them back into this region here. So here is the region from 0 to 2 pi, from here to here. And my two answers, when sine is equal to negative 1/2, well, that's going to be 7 pi over 6 and 11 pi over 6 in the third and the fourth quadrant. And if I add 2 pi to 7 pi over 6, I get 19 pi over 6. And if I add 2 pi to that, I get 31 pi over 6. So these three answers are all coterminal angles, and this is just the sine function. So notice this goes, here is one complete sine function, here's 2 complete sine functions, here's 3 complete sine functions. So here are the 3 coterminal angles associated with 7 pi over 6. And then we have 11 pi over 6, which is the fourth quadrant angle when sine is equal to negative 1/2. The coterminal angle to that is adding 12 pi over 6, which is 23 pi over 6. I add 2 pi to 23 pi over 6, which gives me 35 pi over 6. So these 3 angles are all coterminal with 11 pi over 6. So I now have 6 answers. But this is over a span of 0 to 2 pi, and I want all my answers to be between 0 and 2 pi. So this is 0 to 6 pi, I want 0 to 2 pi. So if we go back and look at our other graph, notice I now have 6 answers. So if I take all of these and divide all of them by 3, so I'm going to get 7, 11, 19, 23, 31, 35. If I divide all those by 3, because I'm doing with sine 3x, I'll get 7 eighteenths, 11 eighteenths, 19 eighteenths, and all the way up to 35 eighteenths. And so there's the answers there. Those 6 answers are the values that we got by dividing all those original ones by 3, because I originally had it out to 6 pi, which is pretty far out there, 18 something, and then I divide them all by 3 or squish them back in, so I get 3 sine functions in a span of 2 pi, and I get my 6 answers. So you find your 2 original answers, on the 0 to 2 pi region, add 2 pi again, find the original one, add 2 pi to that, and then you can divide all three of them by 3, and you have 6 answers. The maximum numbers you can have is 6. So again, I'm going to let 3 theta equal an arbitrary variable w. So I get the sine of w is equal to -1/2. Sine is equal to -1/2 in the third and fourth quadrants, so that's 7 pi over 6, and 11 pi over 6, the third and fourth quadrant. So I need to add 2 pi to both of these, because I want to find the coterminal angles. So that's 12 over 6 pi. So if I add that, I get 19 over 6 pi and 23 over 6 pi. I want to add 2 pi to those as well, because I need to get maximum number of 6 total answers. So I'm going to add 12 over 6 pi again. So that gives me 31 over 6 pi and 35 over 6 pi. So my 6 answers that are equal to 3 theta is equal to 7 6 pi, 11 6 pi, 19 over 6 pi, 23 over 6 pi, 31 over 6 pi, and 35 over 6 pi. So if I want to get theta all by itself, I just multiply both sides by 1/3. Hi, sweetie. So I get 7/18 pi, 11/18 pi, 19/18 pi, 31/18 pi, and 35/18 pi. And notice that 2 pi in terms of 18ths would be 36 over 18 pi. So we want to make sure that all of our answers are in between 0, including 0, but not equal to 2 pi. So 35/18 is less than 36 over 18 pi. So therefore all 6 of these answers are appropriate, and they correspond with the 6 answers that we have on this graph right here. Same exact answers. Okay, so earlier when we had the cosine 2 theta, we had 4 answers. Sine 3 theta, we had 6 maximum answers. So there could be less, but that's a maximum number. So if you have 2 theta, it's 4. 3 theta, you have 6. Say if you have 3 halves theta, so that's 2 times 2 is 4. 2 times 3 is 6. So if we do 3 halves times 2, that'll give us 3 answers. So we're going to have 3 answers for this situation here. So I'm going to let 3 halves theta equal w. So the tangent of w equals negative radical 3. So w is equal, tangent is negative radical 3. That's 2 pi thirds and 5 pi thirds, because that's the second and the fifth quadrant. We need to find the coterminal angles. So we'll add 2 pi, which is the same as 6 thirds pi. So that gives me 8 thirds pi and 11 thirds pi. So 3 halves theta is going to be the same as 2 pi thirds, 5 pi thirds, 8 pi thirds, and 11 thirds pi. I'm going to multiply everybody by 2/3. Again, I said earlier we're only going to have 3 answers, so one of these is going to be no good. So 2/3 times 2/3 is 4 thirds pi. 2/3 times 5 thirds is equal to 10 pi ninths, and this is not thirds, that's ninths. 2/3, so that's 16 ninths pi, and 2 times that is going to be 22 ninths pi. Now again, in terms of ninths, 2 pi is going to be 18 over 9 pi. So 16, 10, and 4 are all in between 0 and 2 pi. 22 pi is too big. So here are my 3 answers for tan 3 halves theta equals negative radical 3.